Now that we have our MongoDB installed and ready to be working, let's go ahead and explore what documents are and how to create them. Well, simply, MongoDB documents are simply defined as field value pairs stored in JSON-like format called BASON, which stands for binary JSON. So let's get our hand dirty with creating documents and saving them in our database. So what we will do is go ahead to our listen folder in our exercise files, and inside of that first chapter folder, which is 2.1, here you can see there is the recipe.json file. Let's open this using our Sublime Text. So as you can see, there's something that looks like JSON because pretty much it's JSON. So here we go ahead and detail what you see. So we have two text fields, the title that says it's a chicken tacos, the description that says it's a classic Mexican tacos, and we have the cooking time, which is basically just an integer. All of these are wrapped inside these two brackets. So there could be multiple key values pairs, and there could be also all kind of data types, strings, integers, Boolean objects, and more. But before we go into details about that, let's go ahead and start inserting some documents in our databases. So let's go to our command line and load MongoDB. Once we are in Mongo, we will get a Mongo shell. One important thing to know is that this shell is just a JavaScript shell. We can write JavaScript here if we want, but first let's connect to the right database. So we will use the recipe database, and we will use it much like we did in the editor. But here we will assign the document to a variable. So we will just call it doc, and we will give it a title of tacos, and we will add a description here of yummy tacos, and we will give it a cook time of 20 minutes in total, and we will close it out right here. And once it returns the content of the value doc here, it means that it worked correctly. Now documents are a lot like rows in SQL tables, so we will need to insert it into a collection. So the way we do this is by db dot wherever our collection name is, we can name it tacos in this case, and then we can use this insert one command, and we are going to give it our variable. If the collection is not already created, this command automatically creates it for you. More about that in the collections later, but they are kind of analog to SQL tables. Let's go ahead and see what our documents look like. So let's do db.tacos.find, and we will get back our document, the title, description, and cook time. You also notice this ID field here. This field wasn't in our original document. The ID field is actually added to every document in MongoDB and generates it for each document like it did here. This field makes the document unique, which it has to be, and it also adds an encoded date time for you. There's a little trick that we can also add to our find command, which is to add pretty at the end, and it will give you a nice formatted document. One more trick you can notice that if you print the arrow in the shell, it will take you to your previous command. In the next lesson, we will talk more about find and how to query documents. The find document is one of the basic MongoDB commands, and if you want to compare it to the SQL statement, it's pretty much like select statement. Now, let's learn how to use find to query our documents and find specific data. To find a document in MongoDB or to query a collection, we use the term find. If you don't pass any parameter or an empty query as well, we can call it, then the function will return all the documents in our collection. And that means all documents match. For example, we can say db.recipes.find, and then we can use empty bracket. I forgot to use a database. And here we get a whole bunch of documents back. If we ask for something specific, like where the title is equal to tacos, we can use title tacos. And I will get just one recipe back. Now to make that look like a lot nicer, we can add pretty at the end like this. Now we can see that this look a lot nicer and much more readable. We can also add conditions. So for example, if we want to match more than one thing, for example, not just the title, but we also want to verify that the cook time is 20 minutes. We can use something like this. Now, if for instance I want to change the cook time to 19, it will be like this. And we won't get any results back. That means that nothing is matched for both tacos and 19 minutes cook time. Sometimes the document might contain a lot more data than you need for your purpose, as you've kind of already seen. By default, find return all the document fields, much like select star in SQL state. If you want to specify or narrow down the fields you want to return, you need to provide a second parameter to find. So in this case, I will switch back to my command to just the title is equal tacos. So now I want to create a query that will return just the title field in my document. To do that, I just add title is 1, and 1 here stands for true. So as I said, this stands for selecting only the title of my document, as you see in the results. You can also exclude fields, so to do that, I can just put 0 instead of 1 to get back everything except for the title. To get back all documents in your collection with just their title, you can send an empty query document and then the title equal to 1, just like this. As you can see from the result, you got back just the titles of documents and it's a little bit easier to manage. Now, what if I want to search for a partial title? After all users of our website won't type exactly the same title. Some will use uppercase, others won't, it depends. So basically, we will need to use wildcard searches. And we do this by using the famous regular expression. Because if you recall, we said that we are just using JavaScript in MongoDB shell. So let's discover how we can do that. Basically, it will be the same as before. We do recipes db.recipes.find, and this time also we want only the title of the document we want to be returned, so we specify that title is 1. So let's go back to our selection criteria. So similarly, I want to select documents based on the title, and this time I'm going to add another bracket and say title $regular expression /taco/I. I here stands for case insensitive, and then close my brackets. And as we can see, we get back 2 documents. In case you were wondering, we can do search on numeric ranges with greater than, less than, and other criteria. We will cover them in our next videos, but for next, we will talk about what we could store in documents. MongoDB documents can store a wide variety of data types, which often makes development easier. So far, we have worked with text fields and numbers, which are quite the same as in a relational database. But what if we want more flexibility? Take this recipe for example. When we think about it, recipes a lot more than just a text or number data. In fact, it has a lot of structure and data that we can see on this page and categorize in our mind. So how do we store it? Okay, first thing that can come to our mind is to copy all these details and pass them as a text in a description key. But then we lose a lot of granularity and options for what we could do with our data later. Say for example, I want to change the serving size of or change the measurement from imperial to metrics. At this point, if you are using traditional databases, then you have a lot of work to do to refactor your data. With MongoDB, you don't have to do that. You can mix and match data together and pretty much store the recipe the way it looked like on the image. I think you start to see why we call them documents instead of rows of data. Let's start with the direction. There are steps and the order matters. sort of like an array. To see how we can store this, I'm going to open up some example in the folder 2.3. In here, you can find two files. There is the direction files and the ingredients. I'm going to open up this with Sublime Text and see what's inside. So as you can see, I have the title and the direction stored as flat out array for the directions. Now, let's move on to another part of this recipe, which is ingredients. So we stored the ingredients of our recipe in ingredients.json. You can see that the beginning of this file looks exactly like the first file until the line 8 where you can find the ingredient. Again, the ingredient value is an array, but this time instead of an array of strings like the directions, it's an array of objects. Not only that, objects has objects inside this. You can actually call this as its own document itself. The nice thing this let us do is store ingredients and their units together yet separately. Now let's import this document to MongoDB. To do so, via the command line, we can use the insert or insert one or insert many. For this example, I will use insert one. So I can do just db.test.insert one title test doc. And that's it. As you can see, it says acknowledge true, and it also gives us an object ID of the document that we just created. So if I do db.test.find, you will see a document with the title test doc and the auto-generated object ID. While the flexibility of MongoDB's document model has many advantages for developers, keeping those documents organized can become trickier. This is where collections come in. As we store more and more of our site's data in MongoDB, inevitably some of that data will be distinctly different. Take these documents for example. We have a recipe, a blog post, and user account. Now, maybe we can store all these documents together by adding a new field to indicate the document type, making it either a recipe, a post, or a user. But at some point, it will become annoying and might cause some performance problems with collections. However, we can keep documents grouped together for simple organization and better performance. You can think of collections somewhat like tables in relational databases, but not all documents need to have the same schema or structure. The collections themselves are then stored inside the databases. We have actually been using collections all along, and it's actually what we have been using after the DB in our queries. For example, if we do db.recipes.find and ask for all documents, and then you just say I want only the title back to keep this a little bit more clear. This gives us all the documents that are in our collection. Now there is a command that you should know to help us with collections and databases. For example, we can do show dbs command. This will show us all the databases in our MongoDB instance. We can also use show collections, and this will show us all the collections inside whatever database that I'm using. If you want to know which database you are currently in, you can use db.getName, which will let us know that we are actually at recipes database. Both databases and collections are created as you use them. For example, we can create collection using insert one like this. So I could use db.coolNewStuff.insert one and then send an empty document, and you can see that it inserted one. And if I do that, show collections, again we can see that we have cool new stuff exists as a collection. And as you can see, I didn't even have to create. It just got created for me. Collections can be named pretty much any UTF strings with the exception of blank or null. Those are not a valid collections name. So now we can store our recipes with our recipes, our users with our users, and our blog posts with our posts collection. There is also an option in MongoDB that allows us to only store maximum amount of documents at any one time, and it will automatically delete the oldest document in the collection to make room for new one. We call this type of collection capped collection. We'll cover more topics like this later in the course. So that was it for how to create documents and query them.